Let us see the last topic of this unit, that is autotransformer. I will write auto transformer like this. This is a core and we are applying only one winding on this limb, right? So if I take two wires from any point, say this point is C point, and here tapping, यहाँ से और यहाँ से एक वायर लिया, so here number of turns will be different than total turn. And if I connect here voltmeter, I will measure a voltage. So voltage measured here and voltage applied here will be different. That means supply voltage here V1 is available across these two terminals with different voltage level V2. So it serves the purpose of transformer, because transformer is doing what? It is transferring power with different voltage level, right? So it is obtained here. So from here what we can say, that auto transformer is a single winding transformer. Single winding transformer, and a part of this winding is common to both primary and secondary winding, like this. In simple manner I can draw. Say this is A, this is B, and this is C. Here number of turns are N1 and here number of turns are N2. Here voltage is V1 and here voltage is V2. So this is single winding, and one part of this winding is common to both, right? And these two windings are not electrically isolated. In case of two winding transformer, as we can see, primary and secondary winding, they are electrically isolated, no electrical connection. But here there is no electrical isolation. Here also you can see no electrical isolation, right? Now in auto transformer power is transferred by conductively and inductively. In two winding transformer, as we have seen, the power transferred only by inductive phenomena, but here power transferred is by both conductively and inductively. Therefore power transfer capability will be more here, and there will be two type of auto transformer. So this is V1, this is V2. Here number of turns N2, here number of turns N1. This is what? Step down transformer. And this will be V1, here N1, here N2, and this is what? V2. It is step up transformer. More turns on secondary, more voltage. So only informative knowledge is essential as per the syllabus. We are not going for any expression, right? So we will write some advantages, limitations and application of this transformer. What are the advantages? Very first thing, As it is using single winding, so it uses less copper, right? Less copper means less copper loss. So better efficiency. Less copper means it will be cheaper also, and it will be small in size also. And in this case, primary and secondary are electrically connected, so leakage of flux is less. Flux leakage will be less. Therefore, regulation will also be better, right? So these are the advantages. What are the limitations? There is no electrical isolation between primary and secondary, right? And second limitation is, in case of step down, say here it is 400 volt and I have a load. This is what? Load, which is of 150 volt. So if fault occurs in secondary, if it is open, then entire 400 volt will be applied to this load, and it will damage load because load is of only 150 volt, right? So this is also another issue related to this auto transformer. Then coming to applications, what are the applications? The very first application, it is used to connect two power systems of different voltage levels. Example, say 400 kV line is connected with 765 kV line. Second application, it is used as a dimmer stat. In labs, right? And also it can be used for dimming the intensity of bulb, and is also used as a starter to start 3-phase induction motor. So this is all about the auto transformer. Let us see voltage regulation of transformer. Say this is transformer having primary winding and secondary winding. So primary winding will have resistance R1 and leakage reactance JX1, because winding is RL only. Supply voltage to primary is V1, EMF induced is E1, and EMF induced on secondary of transformer is E2. This is load voltage V2, right? So when load is open, but this switch is open, then current I2 is 0. Here current will be I1. So when switch is open, this is a switch. When switch is open, I2 is 0. So voltage drop in secondary is 0. Therefore, voltage measured here at the terminal of transformer V2 will be equal to E2, right? So whatever voltage is induced on secondary, same voltage is available at terminal, because current is 0, so no drop. But the moment when it is switch on, when switch is closed, I2 is not 0. Therefore there will be voltage drop, and hence V2 voltage across load will not be equal to E2. It will be different because of the drop, right? So based on this we are defining what? Regulation. So say this is secondary of transformer and this is load. Switch is closed, so voltage across load is suppose 230 volt. So load voltage is 230. Say it is rated voltage of the transformer, but when switch is open, what will be voltage across this terminal? If switch is open, as load is connected to secondary, current is flowing I2, so there is drop also. So whatever EMF is induced, that EMF is providing drop plus 230 volt. So if I open switch, then I will see here voltage is not equal to 230, right? It will be higher, this voltage plus drop. So how this voltage regulation is defined? It is defined as change in terminal voltage, output terminal voltage, expressed as a fraction of full load rated voltage. When full load is removed, keeping input voltage constant at a given power factor, right? So that means if it is 230 volts, so here some voltage is there which is more than 230, because that voltage is providing drop, and after that available voltage is 230. Therefore that voltage which is available here can be measured only when I am throwing off, when I am removing load. So if load is removed, keeping input constant, so the voltage available will be more than 230, say 250 volt. So this is what no load voltage. This is called as no load voltage, right? And regulation will be given as no load voltage VNL minus full load rated voltage divided by full load rated voltage, right? Percentage regulation, you need to multiply it by 100. This is about the regulation of transformer. For better transformer, regulation should be as small as possible. That means drop should be as minimum as possible. That's it.